All right, we're going to take a look here on running an actual repeated measures ANOVA. I'm going to do this for just an overall main effect of a repeated measures ANOVA, and then I'm going to add into it a between subjects variable so you can see how that changes things, and I'll show you also where the post hoc option is so that you can do your analyses as you need to with your data. The beautiful menu here of ANOVA will give us an option for repeated measures ANOVA. So that is where we are going to go. And we are working with our data here that is based on 8th grader data. It's fictional, of course, and stacked to give us results that'll give you some good examples. But one of the things we have in here are these behavioral scores. Okay, so these kiddos are coming from schools where some of them are doing what's called PBIS. It's a behavioral intervention to help support kids and teach them positive coping behavioral skills. And we have a behavioral score for them then at the start of the year and the end of the year. So this is one group of students, and we're looking at their before and their after, right? And we want to see with the same group, is there change within those kiddos? There's a little bit more setup that happens here, right? You can probably tell if you've done other analyses in JASP that this looks a little bit different. We're going to set up this top box here together just to identify what is it that we're trying to analyze. And I would like to stress that I believe it's very important to set this box up and to set it up nice and neat. You could technically move forward with your analysis without doing that, but what's going to happen is your output is going to say things like level 1, level 2, factor 1, and you're going to go, I don't know what that means. So having it identified here will mean that over here, when you get your output, you know exactly what you're looking at and there's no confusion. So we have to define the repeated measures factor, and essentially we're naming that, okay? And we do have two levels. What has been repeatedly measured here? Behavioral scores. So our repeated measure factor is behavioral scores. And we did it twice at the start of the year and then at the end of the year. Okay, and that's it. So it's not a lot of work to do this. You do want to try to not have typos though. Look at that. Behavioral scores. Thankfully, it's not a spelling score. I wouldn't pass. So behavioral scores, start a year, end a year. Take a minute, set this up, and make sure it's tidy so that when you look over here in a second, everything makes sense. What was the start of the year? That's this guy here. We're just going to put it in the box. What was the end of the year? Well, that would be this one here. Put it in the box. And your results start to cook up for you. I'm going to add a couple things to the output. I'm going to add descriptive statistics, and I would also like the estimates of effect size, which is eta squared in this case. Let me shrink this up so we can have a good look at it. We get 3 tables, more than we get in some of our other analyses. The table that I would like to focus on specifically right now is this one here. So this is the within subjects effects. So that means this within the subjects, we repeatedly measured behavioral scores, right? And what happened from the start of the year to the end of the year? Well, we have an F statistic here, we have a p-value, and we have an eta square value. This is our effect size measure. The F statistic is very large. The p-value is very small. The effect size in eta squared, this is a very large eta squared value. What this p-value is telling us is that, yes, this is a statistically significant test. What does that mean in context? We're going to jump on down here to our descriptives to see. At the start of the year, the behavioral scores were at a 0.64, and at the end of the year, they're up to a 1.18. Higher scores in this case are better, and the scores tend to range from a 0 to 2. So what this tells us is that over time, we are seeing a statistically significant increase in students' behavioral scores. Let's write this up. I'll add my note here. First thing we always want to do is say, what did we do and why did we do it? Okay. I ran a repeated measures ANOVA to compare the average behavioral score at the beginning of the school year to the average at the end of the school year. Just setting the stage for my reader. The next thing I'm going to do is to report what happened, right? The ANOVA was significant, and I need to give them the proof of that. And the proof of that is all the googly glop that's in this table. I'm going to type it out, and then I'm going to show you where I got it from. I need to report the F statistic, and that is going to be interrupted just for a second by these parentheses. And then I can put in the actual F value. I'm going to put in my p-value, and I'm going to put in the effect size as well. Okay. I'm also going to tell them, what does this mean in terms of context? The average behavioral score at the beginning of the year, and let me put that here for them, 0.64, 0.27, was significantly lower than the score, than the average, it's called the average, at the end of the year, with a mean of 1.18 and a standard deviation of 47. All right, great, good stuff. So where does all of this come from, and how do I know to say this? Well, first of all, I'm going to say, was it significant or not? And that's going to be dictated by the p-value. Small little p-values mean that it's significant. Technically, anything less than a 0.05, and this is definitely less than that. So I know it was significant. Then I've got to give them all this stuff here, right? All of this strange stuff, but it just comes from right here. It's not hard to find. You have to tell them that F equals whatever it equals. And so this is telling us that F equals 901.657. We do, thank you APA, have to interrupt that a little bit here with these parentheses, and these are our degrees of freedom, and they come from right here. Notice that I put 1 comma space and then the next number, 281. So I'm not writing 1,281 because that's not what it is. It's 2 separate numbers. So do have a little space in there. Then you can give me the F. Then you can write out what the p-value is, FP, and then what the effect size is. This effect size is technically a little Greek symbol of eta squared. I'm just putting the N2 here to hold that space. And when I put this into Microsoft Word, I can insert the symbol and have that here. Okay. The effect size is rather large. And I can report here. I can say that if I'd like, I could put it here. I like to do this with a large effect size of. I like to do it that way. Always consult with the person you're working with on how to write things up. Everyone likes to do it differently. This is just one way to do it. And then we're going to have what the actual behavioral scores were at the beginning compared to the end. And I can conclude that this is significantly lower because of this p-value. Okay. So that's what I'm doing here. Very similar to a one-way ANOVA. The difference is I don't have 2 groups of people. I have 1 group of people, and I'm repeating a measurement within that group, in this case, behavioral test, to see how things change, if at all. And in this case, yes, they did change. They increased significantly. I want to add another piece to the puzzle. I want to ask the question, does this change carry over in both of the districts? So one of the things that's in the data set is this variable district. Okay, so there were 2 districts, school districts that the data came from, and I want to know, does it matter? So I'm going to take that because it's a group, and I'm going to put it in here as a between subjects factor. Between subjects factors are grouping variables, and you'll see that things start to change. Our within subjects effects no longer has just the behavioral scores, but it also looks at the behavioral scores by district to see if there is what we would call a significant interaction. Okay, and that's being reported here. The other thing that we see as well is that the table of descriptives changes. So we have the start of the year for District A and District B, and the end of the year for District A and District B. What we're seeing in these numbers is that District A went from 0.71 to 1.29. So they increased almost 0.6 And District B went from 0.47 up to 0.94, right? And I believe that that was about a 0.46 of an increase. So we are seeing increases, but the increase is larger for our District A than it is for our District B. There's another option here that I want to show you. This is an important one, and it's called the post hoc test. So when we have these numbers, we have more than 2, we need to know what exactly is different from each other. And this option here can tell us that. We can take this and put it here in the box, and it will generate a table. And this table will do all the possible 2x2 comparisons. And we can roll on through here and we can see, this is a nice example. It's telling us that across the board, they're all different from each other. Okay, so District A at the start of the year is different from District A at the end of the year. District A at the start of the year is also different from District B at the end of the year. District B at the beginning of the year is different from District B at the end of the year. District B at the end of the year, start of the year is different from District A at the end of the year. Okay, so we know that they are actually all significantly different from each other. That's important. This is a lot of information. Let's take a minute here to start doing a little bit of the write-up in this context where we're adding the between subjects factor. That will help us digest it a little bit and think about what's actually going on here. So this was very straightforward, I think, especially if you've done ANOVAs before. We're just looking at the difference in 2 different numbers. But now when we add an interaction term, which is another way of saying a between subjects factor. In this case, District A and District B. We have to write our results differently. We've got to start from scratch. We can say that we ran a repeated measures ANOVA. And we need to say that we were looking at behavioral score at beginning and end and compared that for District A and B. All right. When we report out the results, we need to talk about the main effect, it's called. And I talk about that a little bit in my background video on repeated measures ANOVA. The main effect of behavioral score beginning to end of year was significant. And we're going to put the numbers in. And then we're going to say that the interaction between behavioral score and district was significant. And then we're going to put those numbers in. And then we're going to say post hoc tests showed that, and then we're going to put those numbers in. All right. So starting here in this top table, the behavioral scores, this is the main effect of behavioral scores. We have 280, and then this is our F statistic. So we would need to put that number in. 734.43 with a p-value less than 0.01 and an eta squared equal to 0.27. Okay. The interaction, that's the next one here, behavioral by district. We've got to put those numbers in. Oops. And the F statistic on that guy is 8.38 with a p-value of 0.004 and an eta squared of 0.003. All right. So we know that both of these are significant because the p-values are very small. They're less than 0.05. That overall, regardless of district, we saw a change. And that when we break it down by district, we also saw that the 2 districts didn't change exactly the same. Okay, so the post hoc test can help us get some more detail out of that. We can look at this and we can say, all right, well, let's see here. Let's see. District A at the start of the year, we know is different at the end of the year, right? But we also know that the start of the year for District A was not the same as the start of the year for District B. They started at different places. We also know that they ended at different places, right? interesting. We can talk about the means and how the means shifted. That for one group, we saw a shift of almost 0.6 points, whereas the other one shifted about 0.45 points. We can add that kind of descriptive content in here to kind of sum up the results of what we found. This takes a little bit more contextual thinking, right? You've got to ask yourself, what do I want to know here? Do I want to know if this group started different than that group? Do I want to know if the amount of change for one group is important compared to the amount of change for the other group? You got to think about the context and what's important to you. They're all legitimate questions. It just matters what's important to you in your study and your questions. All the numbers are here. They're here for you to use as you see fit. And this is how you generate them. So it's a lot of information on repeated measure ANOVA. I know it's a lot of pieces, but you can rewind, you can go back, you can look at the parts that matter for you and that are important for you in whatever it is you are doing. And do also watch the background video on repeated measures ANOVA because that'll be helpful too. Happy analyzing.